Yeah, I mean, it's really exciting to be the opening keynote for the first time of I hope many, of the Agile Meets Architecture conference. So the title of the keynote is Agility and Architecture Together. And the thesis I want to leave you with is that there's really no conflict, and that actually Agile practices and solid architecture support and enable one another. So in case you missed the Slido QR code, you have one more moment to do that, and we'll be taking questions at the end, so please feel free to collect them and ask them. Quick on my background. So until very recently, I was chief architect and VP of engineering at eBay. I'm going to talk about some experiences that we had together there. I was a senior engineering leader in the early days of Google Cloud at Google, and I've led engineering at Stitch Fix and at WeWork. Over the last 15 years, I've worked at a bunch of different companies. In all cases, I've sort of applied agile techniques and been part of the architecture. So again, my thesis here is that agile approaches and solid architecture aren't just like next to each other and like looking at each other, but they actually enable each other in this, self-reinforcing and virtuous cycle. And as we'll see through this talk, some of the mechanisms through which that happens are both sides enabling constant change of the software that we build through iterative steps and through getting fast feedback. So the way I wanted to structure this was to look at kind of the three things that we're trying to do as engineering organizations. So the first thing that we want to do is we want to build the right thing, right? So we want to provide business and customer value to the people that we serve as software professionals, and we want to also build the thing right. So we want to construct and enable a fast, sustainable flow of changes, both to the software but also to the features. And then finally, I think we shouldn't forget this, particularly as architects, is that we also want to enable a sustainable long-term evolution of the software and the business over time. So we want to build the right thing, build the thing right, and we want to evolve the thing over the long term. So let's start by talking about business and customer value, and I think you'll see how agile practices and solid architecture help here. So in particular, I want to talk about defining the problem that we're going to solve. I want to talk about iterative development, and then I want to talk about features and abilities together, the things that we want to get out of our software. So the first, if you take nothing else away from this talk, you can use these 7 words almost all the time as a software professional. What problem are we trying to solve? I can't tell you how many times as a software engineer or as an engineering leader I've deployed this phrase, because people will tell us to do X or Y or Z, but it's so important for us to take a step back and really understand what problem we're trying to solve and what value we're trying to provide the business and the customers. Why do we care what problem we're trying to solve? Well, the first thing is, and I love this quote from Charles Kettering, is that a problem well stated is a problem half solved. So many times in software, in mathematics, in science, if we can correctly frame the problem, we're so much farther along towards solving it in a good and sustainable way. So we've defined the problem. Do we know exactly what we're going to do? Well, maybe. We have some ideas. If you've never seen these statistics, they're pretty amazing. So this is Ronnie Kohavi, who led experimentation at Microsoft and at Amazon, and I think now at Airbnb. And he did a lot of studies. This was at Microsoft, but 1/3 of the features that people at Microsoft produce, and they're no dummies, they're thinking really hard about it, they understand the customer problems. 1/3 of the features they produce actually produce positive customer and business value in a statistically significant way. 1/3 of the features provide no value whatsoever, make no difference positively or negatively, and 1/3 of the features are actually negative and statistically significant in the negative direction. So 1/3 of the time we get it right, 2/3 of the time we get it wrong. Well, so what are we going to do? What are we going to do in this? We're going to apply agile practices, iterate quickly, learn fast, and try to remove the cases where we're in the 2/3 and amplify the cases where we're in the 1/3. And this is a pretty long-standing, long-recognized problem in our industry. So I hope everybody's familiar with this book by Mary and Tom Poppendieck way back now 19 years ago, 2003, way ahead of its time. Building the wrong thing is the biggest waste in software development. Okay, so how are we gonna attack this? So we're gonna attack this with agile methods. So the traditional organizations that, as I look around, many of us grew up in the early parts of our career, would organize stuff like this. So maybe I have 5 people on my team, or I have 5 teams, or I have 5 business units, and I have more than 5 things to do. And we'll just get everybody working in parallel on one thing. Well, but we have to wait a long time to get any value here. So what if we do it a little bit differently? So what if instead of working on 5 things in parallel, treating the priority 1 thing the same as priority 2, priority 3, priority 4, and priority 5, what if we why don't we double up and try to get the first feature out more quickly, double up, try to get the second feature out more quickly, and then when we're done with those, then we move on to the next thing. So this is the lean technique of limiting work in progress. I think we can do better than this because those feature lines look really long to me. Well, so what if we did something like this? What if we did iterative development? So what if we, instead of working for maybe months and releasing something only at the end and only then learning whether we did a good job or not, or whether it was a useful thing or not, instead, what if we released software iteratively along the way and provided incremental value? So this has, as you can imagine, for every one of the agile people, it's obvious that we should do it this way. It has a lot of great benefits. The one great benefit is when this happens, right? So I can't tell you how many times as a software engineer, when I was working in that more waterfall style, I would be working, and then maybe 7/8 or 9/10 of the way done, and there'd be some change in priority, or we'd learn something different, or something like that, and we'd end up abandoning work that we'd spent good hard time thinking and working on for maybe a long time. But it actually provides a lot more value in a lot of other ways. So one thing you can see is that by doubling up, we're working on the highest priority features first, and we're not implicitly treating the priority 1 feature or work the same as priority 5. We're also delivering incremental value along the way, right? So instead of waiting till the end to get value, we're delivering incrementally along the way, and this is obviously a core of agile practice. We're also delivering value despite changing priorities. So at any time, we can stop and work on something else. And at most, we've lost a little bit of time, but we provided a ton of value along the way. And then finally, back to that very scary Ronnie Kohavi set of statistics about the value of features. It enables us to experiment and learn along the way, right? So if we've gotten to a certain step and we're getting positive value, we can continue investing in that thing. And then if we are in the 2/3 case where we're providing no value or it's actually providing negative value, we can abandon it and try something else. So the last thing I want to say about providing business and customer value is the very direct and very obvious contribution of architecture here, right? So, I think a lot of us have, worked in organizations where maybe the leadership is thinking only about features and not, not about the other aspects of software, the ilities we like to say. And the way I like to frame it as an engineering leader to my business and product counterparts is that these kinds of ilities, and I'm sure Uwe will give us a lot more, in his talk later. These architecture ilities we should think of as priority 0 features, right? It's implicit and obvious and important that we invest in correctness, that we invest in performance and scalability and reliability and operability. That's our job as software professionals, and particularly from the architecture lens. And it's also obvious, but it's sometimes good to say explicitly, that it doesn't matter how beautiful the UI is if it's not up. Okay. So we briefly toured providing business and customer value. This is again about building the right thing. Now let's talk about building the thing right by enabling a fast, sustainable flow of change. And here I want to talk about structuring our organization around empowered teams. I want to talk about modular architecture. I want to talk about moving forward in small steps, and I want to talk about getting fast feedback to our software and about the features that we build. So again, back in those traditional organizations that some of us are old enough to remember, we used to structure our organizations in this way, right? So we'd have one team that would come up with ideas, and maybe we would call them business or the product, and then we would have a separate team of well-paid typists. Lots of us in the room would maybe be those people, and we would furiously develop our software, and then we would throw our software. We wouldn't, of course, test it. Why would we do that? We would because there's another team that would do that. We would throw the software over the wall to through a quality assurance team, which would then decide and help us decide whether we built good software. And then after that, we would throw it over the wall to some team to operate the software. Well, we've learned over time that this isn't a great way to build software. All these handoffs slow us down. It diffuses responsibility, and we don't end up getting very good software or very good features. So instead, what we've learned again from agile practice is to co-locate all those responsibilities within a single team. And the new term of art, which I love out of the team topologies book, is we're talking about stream-aligned teams. So teams that are organized around a particular customer or business problem. As a technical matter, they're going to be building a single service or application, or maybe a small set of related services and applications. And each of those teams has a set of clear goals and metrics that matter to customers and the business, so they can, for themselves, figure out whether they're doing a good job and making forward progress in what's important. It's very important that those teams be independent. So what does it mean for a team to be independent? It means that the team has all the required skills and capabilities within the boundaries of the team to solve the customer problem. Now, that doesn't mean they do all things. I've never had a team where we built chips and firmware and at the same time built JavaScript in the UI, but putting together the vast majority of skills that we need to do our problem is the best way to build good software. And so what this allows us to do, obviously, is the team is able to design, to develop, to deploy, and operate its services and applications independently of other teams. And then I think this is a critical aspect out of the kind of DevOps and SRE idea, is that the team will own the services and applications that it builds from end to end. So starting from the beginning, from the cradle, all the way through to the grave. And as an engineering leader, one of the kind of goals, I guess, or ideals that I like to set for myself in terms of how to organize teams is I'd like to see if we can get 80% of a team's project work within that team boundary and not requiring a lot of coordination between other teams. I kind of made 80% up, but I like the 80-20 rule, idea of that number. And it's very true that in every situation that I can think of where it's the reverse, where like 80% of the work within a team does require detailed, fine-grained coordination with other teams, that usually indicates that team is dysfunctional, or more likely the organization is dysfunctional. So this is my goal as an engineering leader in terms of how to construct an organization that's effective. And then when we put that all together, it looks like this. So it looks like an organization where we have teams that are organized by individual domains. Those domains matter to the business. Those teams co-locate, generating new ideas, developing them, ensuring their quality, and operating them in the real world. And then that allows us, with those little, circles, that allows us to do fast feedback loops and get better over time. Okay. So this is kind of the organizational lens of how we would do a fast flow of change. Now let's kind of flip a little bit to the architecture lens that enables us to do it in that way. So the first sort of obvious thing to say here from an architecture perspective is that in order for teams to be independent of each other and be able to make forward progress separately from each other, we need to have a modular architecture. And so what does that mean in practice? That means that we have service boundaries that are maintained by one or where individual teams maintain one or small number of them, and those matched very directly the problem domain. Those service boundaries encapsulate both the business logic and the data, and so all the interactions that we have with that service are through the published service interface, and there's no secret backdoor where I can read and write from your database behind your back. That way lies madness. And then the other thing that I want to say here is that those service boundaries don't just encapsulate logic and data, but they also encapsulate those architecture ilities, right? So that boundary of a service or an application is a fault boundary. So when there are problems, so we can keep it encapsulated and isolated to that particular component of the system. We can do performance optimization behind that boundary, and then also super critically in the modern world, that's a security and a privacy boundary as well, right? So the more we have those individual boundaries and we secure them separately, the more secure our overall system is going to be. So modularization is about a vertical slicing of our overall problem space as an organization. Which enables us again to move fast. A horizontal slicing of that is around providing and leveraging a common platform across as many of those components as we can. And so. So here I want to argue for, the high-performing organizations typically provide a common development platform with infrastructure and a platform that makes it easy to develop and maintain services and applications. So those things provide common capabilities, like monitoring and authentication, that sort of thing. They provide standard frameworks, one or a small number of standard frameworks across the company. They provide things to enable the development experience, and then high-performing companies like Netflix and Google are really well known for enabling this paved road. And why does this make things easier and faster for those streamlined teams? It's because it provides a separation of concerns that reduces the cognitive load on those streamlined teams. They only have to think about the business problem that they're solving in their domain. They don't have to think as much about how to monitor and how to do a bunch of the other infrastructure or platform related things. And then the way to think about that as an individual engineer is that it actually reduces the amount of decisions that I have to make, right? So because I like to call them enabling constraints, because the platform constrains the thing that I do, that actually bounds the kinds of decisions that I need to make and actually allows me to be more creative in the area that actually matters, which again is that domain or business or product area. Okay, so that's vertical and horizontal, and now I want to move into the third dimension. So the other dimension of separating those teams from each other is separating them in time. And so the best way that we know how to do that in software is through communicating between services and applications in an event-driven way, right? So there's some important thing that happens in service or application A, an event gets produced, service or application B that cares about that event, listens to that event and reacts to it when it needs to. And so why does this matter? It matters because we're decoupling those two domains and those two teams and abstracting that communication through a well-defined interface. It also allows those two things to be asynchronous from each other, right? So we don't have to have that A thing happen at exactly the same time as the B thing. And moreover, it allows us again to decouple those operations in time. So the A thing, so it allows us to decouple the availability of A and B, right? So A can be up and producing work and producing events, while B might be down temporarily. And it also allows us critically to be able to scale those things independently. Maybe A needs to take a lot of traffic, so we need to scale that up a lot. But B doesn't need to do that, so B doesn't need to be scaled in the same way. But this asynchronous communication between A and B is what allows us to separate that availability and that scalability in time. Okay. So now the next thing I want to talk about is while I'm within the team doing my work, I want to do work in small steps, right? So why do I want to do that? Well, we already talked about from a kind of business and customer value perspective that by moving forward in small steps, it allows us to experiment and iterate and learn and potentially go different directions. It's also important from just a team software health perspective in terms of developing a fast flow of change, because those small incremental changes are a lot easier to understand, they're a lot easier to code review, they're a lot easier to test, and they're a lot easier to roll back. So a little personal story, actually I'm gonna say that in just a sec. By contrast, large changes are a lot riskier. And in fact, the risk of a code change is not linear in the size of the change, right? It's not like a 100-line code change is, twice as risky as a 50-line code change. It's a geometric at least. It's, 4 times or maybe even, 10 times more risky. Why? Because all those 100 lines potentially interact with each other and with other parts of the system in ways that maybe we can't keep in our brain. And so by by keeping our changes small, it allows us to move forward faster. So a little personal story. So when I first joined Google, I was joining to be, the director of engineering for App Engine, which is Google's platform as a service. But I got great great advice from my boss, who said, well, the way to be really effective at Google is to have built a service and deployed it into production. And so he allowed me, and I was very excited to be able to be an individual contributor for the first couple of months that I was part of the team, built a new service, released it, built a team around that, handed it off, and then kind of took the leadership role after that. Because I thought, because I was going to be working with this team and I was building this service, I wanted to do a really, really good job on my first thing. So rather than releasing, things incrementally in maybe like 10-line or 100-line chunks, I stored it up and I released 1,200 lines of change for this new service all at once. And nobody said to my face that they were unhappy about it. But the guy, and I still remember poor Nate on my team who reviewed it, it took him 2 days to review this code change. And we went back and forth probably over a week. I mean, he gave me some great feedback. It actually ultimately grew to 1,800 lines. And this is just, even though I know this stuff, I still didn't do it. So it's one of those things that I always remember. And sorry, Nate, I'll do better next time. Anyway, large changes are really risky. They're horrible for the people that review things. And a lot of times, Nate didn't do this, but a lot of times you give somebody a 10-line code change, they'll find issues. You give someone a 1,200-line code change, they'll say, looks good to me. All right. And then the other aspect, again, of doing things in small units of work, this is, again, obvious to the agilists, is that we're always in a releasable state. We've only made a very small change, and it allows us to actually and counterintuitively increase the overall rate of change of our software, but reducing the risk of those individual changes because we're making them in small forward steps. Okay. That's about taking small steps. Now let's talk about verifying and validating that those steps are good. Well, how do we do that in software? We do that by testing. So I don't think I probably need to convince you that testing is a good idea, but I will try to convince you, if you're not already convinced, that testing actually is an investment that allows us to go faster and move more quickly. So why is it that tests allow us to go faster? It's because tests give us the solid ground to move forward. So I'm a runner, and sometimes when I really want something hard to do, I'll run on the beach in where I live in California, and that's really hard because the sand is slipping under me all the time. It's a lot easier to run on something that's really hard. Why? Because it's solid ground and allows me to move forward and I don't slip back. So tests are what does that for ourselves in software. And this is a picture actually taken that I took in Budapest, and it's one of those funicular trains. We also see them in the Alps, right, where the train is on a rack rail and it moves forward. Chunk, 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 chunk. And that center rail allows the train not to slip back on the steep slope. And the way I like to think about it is every time we add a test to our software, chunk, we've moved one step forward and we can never slip back. Okay. Tests help us go faster. Tests also help us make better code. Because why? Because it gives us the confidence to break things. I'll try radical things if I feel confident in the tests and in the solid ground underneath me. And it gives us the courage to potentially mercilessly refactor these areas in ways that we've learned could be better. And then they also obviously make better systems because it allows us through our process to catch bugs earlier and fail faster. The very best, in my personal experience, my best experience of strong testing, and in particular test-driven development, was when I worked as the engineering leader for Stitch Fix, clothing retailer in the United States with a ton of machine learning and data science. It was about a 125-person engineering team, but basically we didn't have a bug tracking system. It's not that we didn't produce bugs, we definitely produced bugs, but we had built up over time a suite of tests and a discipline around Every time I'm about to write a piece of software, I write the test first, and then I build the software behind it. And what that allowed us to do is not only build up that suite of tests to make us feel good, but also it allowed us to be like inbox zero with bugs, if that makes any sense, right? So it allowed us to, we would catch so many bugs, over time in our process that we didn't have that many bugs that leaked into production. And when they did, we had a small enough number that we could kind of just stop what we needed to do and fix that bug right away. So we didn't have, as I've experienced in almost every other place that I've worked, this big, long backlog of hundreds upon thousands of bugs that just made us feel, really horrible. Instead, that backlog wasn't a whole bunch of bugs we wanted to fix. It was new features we wanted to write, and then very explicitly pieces of technical debt that we intentionally accrued and that we want to repay later. Okay, so after tests, we want to deliver software. I've done this at a lot of places, including eBay, but maybe the best example is at Google. So, continuous delivery is about having a repeatable pipeline where we build our software, we test it, we secure it, and then we deploy it. And then that pipeline returns a definitive result, yes or no. If it's yes, we can choose to release it anytime. If it's no, we have some work to do. At Google and also at eBay, developing capabilities to automatically roll out and roll back the software. So we're automatically monitoring, SLOs and changes in production. We're monitoring those production metrics. If the metrics look good, we'll keep going and rolling it out farther and farther. If they don't look good, we'll roll things back. And then again, this gives us the capability not just to build things in small units of work, but to deploy those small units of work all the way out to our customers. And what I love is that it makes deployments routine and boring. And again, it allows us to release those small units of work. And again, from an agile perspective, it gives us that tight feedback loop that allows us to build things and measure and learn from them in this very quick cycle. And again, it's super obvious that like the idea here is agile, but the implementation is architecture. Right? Okay. All right. So the very last thing that I want to talk about here is around, so we talked about building the right thing, building the thing right, and now I want to talk about evolving the thing over time. And so here I want to talk about, finally get to that, that design question. How much should we design? So as a hint, I think it should be an 80-20 rule. I'll talk a little bit about evolving services, particularly in a large service ecosystem, and then I'll talk about evolving architecture in the broad sense. But first, why do we have to evolve at all? I mean, why didn't we just get it right the first time? Don't we sometimes get asked that? Why didn't we just, if we knew that, we were going to have to, someday serve 1 billion customers, why didn't we just build the thing that served 1 billion customers up front? Well, because when we started, we were serving 100 customers or 1,000 customers or something like that. So it's obvious, but I think it's sometimes helpful to be explicit about it. What things evolve over the long term in our product and our organization? Well, the first thing that evolves are constraints and capabilities, right? So, we look at the history of, eBay or Netflix or Google or any of the companies that you or I work for. User growth and scale evolves over time. Also, concurrently, our organizational size and our organizational skills and our organizational capabilities and resources also evolve over time. So the things that were appropriate for us to do when we were a very small team and we fit around a conference table are not the same things that we should do when we're a 100-person, 1,000-person, 10,000-person organization. And conversely, the things that the 10,000-person organization can do and will do are not the appropriate things for when you're starting out. Again, it's obvious, but a lot of times, we have a little bit, maybe when we're the small team, we have an envy of the big organization. I've certainly felt that. Anyway, okay, constraints and capabilities evolve, that's obvious. Also, the problem itself evolves. First, it evolves because maybe we've solved part of the problem and then we only then discover, other parts of the problem, or more likely, our customers come back and tell us, yeah, you solved part of the problem, but there's other parts of the problem that you haven't solved yet. The competitive landscape, market conditions are evolving, of course, and then also, frankly, our understanding of our domain evolves. So in every case where I have built a system in the small, I thought I knew how to decompose the domains correctly. In all cases, I was wrong. But I didn't, I didn't have enough knowledge or experience to know that I was wrong in the beginning. That doesn't mean I should give up and not start. It means that I should be open to having things evolve over time, which is what we're gonna talk about in a sec. And then the other thing, of course, the solution itself is evolving. Again, like I say, our domain decomposition evolves as we learn more about those domains. We might get richer and deeper in particular domains. We might kind of back away from some of them. And then also, again, it's obvious, particularly over the landscape of the time that most of us have been in software, the technology landscape and approach has evolved a lot. Open source, cloud, services, all these things have evolved substantially. So the way that I would have done any particular thing 10 years ago or 20 years ago is radically different than how I would have done it now, simply because keeping everything else the same, simply because the technology landscape and what is the appropriate and easy approach in 2022 is very different than what it was in 2012 and in 2002 and then in 1992, where I was also working in software. Okay. Big design up front doesn't work. Let's just say that out loud. And also, no design up front doesn't work. Again, the old style, writing a big spec, 1,000-page spec, and then having somebody implement it, that doesn't work. We learned that for a long time. But also, you've probably had these experiences, but I certainly have, where developing software is kind of a Markov process where you have no memory of the past. That's also wrong, right? So the way to do it, and again, it's obvious, but sometimes these obvious things need to be said. Lots of times to our colleagues, is we really want to design things in an 80-20 way. What does that mean? That means that I want to use my brain. I want to think maybe more than a little bit up front, but not for months and years. I want to do a minimal design to get things started, and then as soon as I possibly can, I want to get something out there to somebody who can give me feedback. And so the way to do that in the small is with prototypes. The way to do that in the large or with transformations is with a pilot. And we want to adapt based on that real-world feedback. So we know a little bit to start with, but there's a lot of things that we don't know. And then we want to have a discipline of getting and incorporating that real world feedback as early and as often as possible. Okay, so let's talk about that in the context of evolving services. So the largest service ecosystem that I've worked in is Google. There are probably today tens of thousands of services at Google, and it's a vibrant ecosystem, right, at large scale. So it actually is very much like evolution in the biological ecosystem sense. So over time, as good engineers notice opportunities and notice new problems to be solved, they work together and figure out how to create and extract out new services when we need to solve a new problem. But also, a service that nobody's using. The service is only providing a value when somebody's actually using it, so they kind of justify their continued existence by being used. And then when services are no longer valuable, no longer being used, they get deprecated. And then the other aspect, which again is obvious, but just kind of to say more explicitly, is that the domains of our problem space end up growing and dividing over time. So again, from a biological sense, the metaphor that I like to use for myself is cellular mitosis, right? So as you learned in biology, every one of us starts as one cell, divides into two daughter cells, those divide into two daughter cells, blah 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 blah, until each cell becomes some skin or some part of your heart or something like that. Anyway, so these services evolve over time, and again, at very large scale, this can be very dynamic and very a little bit confusing. So there's a kind of an engineering proverb at Google, which I always find so funny. It's that every service at Google is either deprecated or not ready yet, or that's sometimes how it feels when you're part of it. Okay. So the last thing that I want to talk about is evolving architecture in the large. And I think what you're going to see, there are going to be a lot of obvious lessons to take from this, but the ones I want us to take are kind of why agile practices and small units of work and feedback really allow us to evolve architecture over time. So again, as I mentioned, until very recently, I was chief architect and VP of engineering at eBay. And eBay is on, depending on how you count, its 5th generation of its software. So it started out famously in 1995. Pierre Omidyar, the founder, had a 3-day weekend, actually this weekend, Labor Day weekend in the United States. So exactly 27 years ago now. And he built it in Perl. Every item was a file. He wasn't intending to build a business or build a scalable piece of software. He was just playing around with this new cool thing called the web. V2 of that was a monolithic C++ monster. Over several years, it grew to be 3.4 million lines of code in a single ISAP DLL. So if you recognize any of those words, you're shuddering and crying inside. We were actually hitting compiler limits on the number of methods per class. And I'm embarrassed to tell you that I know that at that time, you could have 16K methods per class in the Microsoft C++ compiler. So, and we were hitting that limit. So, you guys think, maybe some of you think you work in a really bad monolith. Like, let's talk afterward, because I don't know. Okay, the next iteration, which was modern as of 20 years ago, was a re-implementation which we called V3 in Java, and it wasn't really what you would now call microservices, but it was sort of mini applications. So rather than the entire everything about eBay being in that one DLL, essentially that one class, instead it was divided up into roughly 200 different applications or services that had parts of the site. So, one for buying, one for selling, one for paying, et cetera, times 200 different, domain decompositions or mini applications. And then now there's a V4 and there's a V5. We call them something different internally. But now it's fair to characterize eBay as a polyglot set of microservices. Okay, so Twitter's gone through a similar evolution. So it famously started as the world's largest Ruby on Rails application, which they codenamed the monorail. They broke out a bunch of the front end into JavaScript, a bunch of the back end into services, mostly written in Scala, and now you can call Twitter a polyglot set of microservices. Amazon has gone through a similar evolution. So around the same time as eBay was moving from V2 to V3, Amazon was moving from a similar monolith, which was a Perl C++ hybrid, into a more service-oriented architecture. And they basically spent the years 2000 to 2005 retooling their entire infrastructure and software around service-oriented architecture. And in case anybody thinks that architecture doesn't matter, 2006 is when AWS started and when Amazon started taking over the retail space of the entire planet. So again, architecture really, really matters and flexibility really matters. Okay, and then now it's fair to characterize Amazon having iterated many more years as a polyglot set of microservices. So you can see that the successful companies maybe that we admire or we fear have all gone through many iterations of architecture. Okay, so one thing I like to say is that if you don't end up regretting your early technology decisions, you probably over-engineered. It is very possible that there was some mythical company in 1995 that instead of building an ugly monolith like eBay and Amazon did, instead they built a distributed system. But there's a reason why we've never heard of that company, because they didn't serve their customer needs. So there you go. So the last thing I want to talk about in architecture here, or in long-term evolution, is about some of the work that we did recently at eBay and how software delivery capabilities actually enable us to improve architecture or our prerequisites to doing it. So I was part of leading a 2-year program that we called the Velocity Initiative, and our goal was to improve software delivery at eBay. How did we do it? We did it with exactly agile and lean methods. We would go to teams and we would say, hey, it looks like you're deploying once or twice every month. If I told you you had to deploy every single day, tell me all the reasons why you can't. They would give us a big long list. We would merge sort those lists together from all the different teams, and we would say, great, you just gave our platform team their backlog. And I ran the platform team, so it was really helpful and easy for us to do all that work. So what would it take to deploy your application every day? That's a kind of agile question. We were able to double the engineering productivity of the teams that we work with. So what does that mean? That means holding the team size and composition constant. They were able to produce twice as many features and bug fixes as they used to. We also moved a bunch of this kind of accelerate or DORA metrics really well. So we improved the deployment frequency of those teams about 5x. We shortened their lead time between committing code and deploying code to 5x. We also improved the quality in terms of improving the change failure rate and the mean time to restore. So that's all great. But how does that connect to architecture is one of the reasons, we want to make a lot of changes to eBay's architecture. So there's still lots of opportunities for us to improve. But what we saw very clearly was rather than starting by changing the architecture, we really needed to start by changing our ability to deliver software. And if we could deliver software faster, that would give us the opportunity to make small changes and allow us to iterate our way toward making big architecture changes rather than doing it in one big chunk. And I don't know, any of you who have tried to do a big kind of monolithic replacement of an architecture in one big chunk, you probably will have experienced this wonderful quip from Martin Fowler, which is the only thing that a big bang migration guarantees is a big bang. Okay. Well, so we talked about how agility and architecture can be not just next to each other, but also be self-reinforcing. So we talked about building customer value. We talked about building the thing right in terms of a fast, sustainable flow of change. And we talked about how we can long-term evolve our product and our service and our business over time. Again, I just want to leave you with this idea that an agile approach enables solid architecture by allowing us to iterate on it, again, in small units and also get fast feedback. But at the very same time, the only way we're going to make those small units of work is if we have a solid architecture to begin with. And so that enables our agile approach. Okay, so thank you very much. This is the same, this is the QR code that we had, and I think we might have some time for questions, but thank you very much. Thank you very much.
We've got some questions.
Great.
I'll allow you to
okay, sure.
take a sneak peek.
Oh, thanks. Yeah. How do you work together with external suppliers to create end-to-end responsibility? Boy, I feel like there's a lot of context behind that question that I don't have, but I'll guess. Might be possible. Whenever I want to work with some other team, whether it's internal to the company or external to the company, I want to collaborate with them. So rather than thinking about what that external supplier might need or might be able to provide and doing that in one go, instead collaborating and talking with them and exchanging ideas over time. So, in the internal model, again, the examples that I was giving about the platform team at eBay, talking with our customer teams about what they might need or want, and then meeting that directly. And then also, when we're building those service interfaces, negotiating the interface or iterating on the interface before we start building, and then build a prototype and do that. Again, I might be missing a bunch of the context of that question, but feel free to come up afterward and give me more context.
Let's take the next one.
Okay, how do you make services discoverable for other teams if the teams are working independently? Oh, that's great. Well, working independently, this is obvious, but working independently does not mean ignoring the existence of other people. Does that make sense? Honestly, in most of the places that I've worked, the discoverability, so you can build a catalog of services. That's a standard technique. Honestly, I've never seen one of those catalogs be by itself super interesting and useful. But what I have seen is great documentation about the individual services being the way that teams can self-serve with other teams. So I'll give like a specific example. So let's imagine, because this was true, I was a service owner at Google and I want to figure out I have stuff I want to build, so I kind of look around or ask around my peers, like, hey, how do you do this thing or that thing or the other thing, and kind of learn where this other service might exist, and read up on the documentation and go from there. So yeah, the discoverability. I think a lot of times, frankly, as engineers, we want to do engineering solutions, but I'll just say in practice, a lot of times when I want to discover another capability of services, like I ask, usually the human mechanism or the human communication is the best way that I've found to do that. Your mileage may vary.
Let's take 2 more questions.
What is a team? Yeah, what's a reasonable team size to be able to own a service from the start to the end? Oh, that's a great question. It depends, as with all interesting, questions. I will say this: if it is 1 or 2 people, probably that service is small. That's not bad, but it would mean that the team. So let me take a step back. I think teams are most healthy in the 6 range, 5 or 6 range, plus or minus a little bit. Let's just start from that. Like, that's a good, healthy set of team unit. So if there are a bunch of small services that are really easy, where individually they might be able to be maintained by 1 or 2 people, that team can own several of those, and that's great. If you ever have a service, and this exists, but like if you have a service where really you feel like it needs to be 10 people or 15 people or 20 people, like there's an opportunity to divide that service into smaller units, if that makes any sense, right? I would be surprised if, in the steady state, you would need that large number of people for a single service. The customers might experience some big service as one thing, but it's might be made up of a bunch of small individual ones. I hope that makes sense.
And the last question.
Last one. Great. Okay. As you mentioned, tests help us to move faster, but they resist change as the software evolves. How do you minimize the problem of tests slowing development down? That's so good. I love it. Can I give you a resource, and then I'll answer your question? So the very best YouTube channel that I personally know about, I don't know them all, is the Continuous Delivery channel by Dave Farley. And I would strongly recommend that all of you, but like the asker of this question in particular, check out a bunch of the short videos that Dave does. So how do you make it so that tests don't slow you down? So the implicit, and I've experienced this too, I've done this too, so don't feel bad about it. What's the problem behind your question? The problem behind your question is that the tests have encoded implementation details. So as I change implementation details, I have to change the tests. So the reframing in your mind is to try to make the tests not about implementation details, but about what the units, what the class does, what the component does, what the service does, and come outside in, like come from the customer/user perspective and frame the tests in that way. And every time you feel like, well, no, I actually want to test this implementation detail, like think again, because you want to be able to change those implementation details like behind the back of your customers. It's a hard change in your mental model, but it's well worth it. And that discipline around behavior-driven development and test-driven development is really valuable. Okay, so I think we're out of time. Thank you so much. I hope to see everybody at the conference.